Alright, so I'm going to give a full rundown of this thing. I'm pretty impressed with it, and I don't know. We'll see what my plans for it are going to entail. I've got a smelting operation. I want to do some smelting of some lead, and this will do it. So that's why I've got the port here. This is going to be where the metal comes out, drips down into a drip pan basically. I'll be able to block it off whenever I don't want to use that. I've got my 3 Venturi burners. Well, they're not Venturi anymore. It is forced induction now. But I'm running 030 MIG tips in here. Feeds down into a splitter block from the gas line with a quick disconnect so I can easily move everything around. Got my temperature gauge. I've got a variable speed controller here that I can control the speed of my fan. It works okay. I maybe get about 20 or 30% control over it. Not as much as I would like. I would like to be able to really just control it with this. If anybody's got any ideas on how to, I know I can do it with a DC controller because that is a universal motor. This is an AC controller. It's designed for routers. I just picked it up at Harbor Freight for like 17 bucks. But it only decreased the speed by maybe 20 or 30%. So it's kind of interesting. It works, I think it's a Triac or something. I don't remember how it works, but excuse me. We got a PID controller here. My thought was to initially set up a PID controller to control my gas flow with an on-off switch, because once I'm above about 2,000 degrees, the gas auto ignites. The propane will auto ignite once it enters the chamber. So if I set it at like 2200, I could sit there and idle it at 2200 degrees by just controlling the gas flow. That was originally how I was going to set it up with the Venturi burner. That didn't plan out because I couldn't get hot enough for what I was wanting to do. I also came out to find that forced induction is more efficient for the same fuel usage. And this is what you're going to have a hard time finding anybody really confirming. But I confirmed it 100%. There is no questions. Venturi burners are good if you just want to get hot cheaply. You know, you can buy the parts for about 25, 30 bucks. Put them together and they'll get you an aluminum smelting furnace. They're not going to be the most fuel efficient, but they'll work. I've seen people sticking hair dryers on the back sides of the Venturi burners, and they work to get you a little hotter, but you have no airflow control. You know, it's an on-off switch. This is my blower. It's actually a vacuum motor. It's a Lamb vacuum motor, 3-stage. I just had it laying around, so I didn't pay anything for it. It's just kind of, it was actually on a dust collector for a chop saw, and I didn't use it anymore after I got out of woodworking. So I've got it here. I set up this throttle plate, so I just cut it out on my CNC, and I can adjust the airflow very, very finite. Easy to adjust there, and then if I do want to get into doing some adjustment here, I can turn my knob up and down. I've got my fuel flow over here, so I've used an argon regulator. You do have to swap the nipple, the nipple works, but the nut on an argon bottle is different than on a propane bottle, because the propane's a left-hand thread, the argon's a right-hand thread, so you'll have to swap those out. I've got my pressure gauges. So I've got my tank pressure sitting at a little over 100 psi there, and I've got my running pressure here. So I can run anywhere from 10, 20, 30 psi, and just keep an eye on it for what I'm running. And it works really good. I did a trial to test out what controllability I would have, and I sat at about 2350 degrees. I was able to throttle it and just kind of let it sit there. It sat there for maybe 5 minutes, fluctuated maybe plus or minus 5 degrees, really idled nice. So really good as far as that goes. I could tweak the airflow or tweak the fuel flow, and you would see the temperature drop if I added fuel and raised the airflow rate, the temperature would rise quick. So then I would bring it back. You know, just kind of played with it a little bit, learning the abilities. So it's like a gas pedal, but it has two controls. So without a computer, you're just not going to be able to monitor that air-fuel ratio and optimize it. But you can listen to it and you can watch the temperature gauge and optimize it for the temperature. So that really is where it came down to. The next thing is I've got my pedal. So I can step down on my pedal and rotate the lid out of the way. Works really nice. I like that. It's slick. So just let it up. Inside there is my 3 Venturi burners. They are not cast in place. I can replace them. I've got some stainless parts coming for those to replace. And yeah, it works quite slick. I ran it up to I think 2,800 degrees, and this is a ceramic radiator element out of a grill. It's going to be my Tiru, whatever, for my blast furnace. So I had it sitting in here, and as you can see, the damn thing started to melt. Literally. So that is how hot this thing got. Is that ceramic was getting eaten away at temperature. It melted off the little plastic ferrule here, so I pretty much ruined that guy. And yeah, can't complain too much. But I can't run it up to 2,800 degrees very often, that's for sure. So if I ever was to do steel melting, which I believe we're sitting at around 2,600 for steel melting temperature, or somewhere around in that range. I wouldn't be able to run that for a component. I'd have to plug off that port. But yeah, so that's kind of what's going on. So if you see what's going on down here, I've got my pipes feeding. Let's see if I can get a better shot. So I've got them split into a bend. I just had some weld L's laying around. Goes into a straight tube, and then I made kind of a triangle out of those 3. They are all completely welded up. Just kind of tack welded. I used some EMT couplers. I split them, shrunk them down, and made them to where they're removable. So if I ever need to work on any of this, all I got to do is disconnect the EMT tube, slide it down, and I can unthread or do whatever I need to do to all of that. Pretty easy. So just kind of fabbed it up. So that's a rundown of my kiln. I guess I could fire it up and show you guys what it does. So the way I like to fire it up is I'll pull out my port. I've got my gas turned on. I'm going to turn my airflow on. I'm going to go ahead and add a little fuel while I hold. I'm going to have to set my phone down real quick. There she is, burning around in there. And like I said, I can go ahead and plug this guy back up now. And I can kind of fiddle with my airflow. Let me get a piece of metal here. And listen to the difference in the torque or the burn, and tell you whether it's running rich or lean. And then once I get into a dialed in zone, I can kind of adjust that. I'll tweak my fuel, turn my fuel up, turn my fan up. my fan a little more. And she'll start to rip. Getting a little shaky there with the flame. I think I'm running too much air, so turn the fuel up. And now you can see that flame smooths out. So I was running on the lean side there, but now that you get it back into the right air-fuel ratio, it runs. So it's just a matter of balancing that air-fuel back and forth. Guys with forges can probably tell you more about that, but there's not a lot of guys running the kind of burners. They're running Venturi burners, so, or not Venturi, they're running ribbon burners. So this is more along the lines of a Venturi burner. I'll go ahead and shut it down. I just turn off my gas, turn off my fan, close everything up. That's it.